Hi, I'm Ed. I lead our developer advocacy team here at IBM UK, and today I'm going to run you through some natural language processing and how you can get started really quickly to be able to build something with the hackathon around Call for Code. What I'll run you through is very quickly just an introduction to NLP for anyone who hasn't heard of it or isn't aware of what it's capable of. And then we'll get very quickly on to how you can actually build stuff and do it in as fast a way as possible in order to be able to see results. So we'll talk about using public APIs to retrieve information instantly, using pre-trained models, and then finally, if you need to, building your own model, how you can do that in an efficient way given the time scales that you have. Okay, so what is natural language processing? Well, it's really the intersection of three different fields. The first of those is linguistics, which, if you haven't heard of it before, is essentially the study of language, the syntax, and the meanings and grammatical rules that society attach to those. Essentially anything to do with language and its history and its formation, all falls under linguistics. The second field is computer science, which we're all familiar with, building applications, working with computers. And then the third field is machine learning, right? And if you were to take the kind of intersection between the three of these, this is where natural language processing fits. NLP is actually all around you, even if you're not aware of it in a lot of day-to-day use cases. You'll see it a lot. Some of the top ways in which it's used are things like language translation. We've probably all used Google Translate at some point to try and get by while we're abroad. That's a perfect example of natural language processing that's going on in the background. Speech transcription, the ability to take this video that I'm speaking to now and then automatically create a transcription without having to have a human write it down. Sentiment analysis, used a lot in marketing to try and understand how people think about products and companies. And then, things like Google Home and Alexa, all those voice assistants that we might have in our houses and use day to day, that's using NLP, from start to finish, right? It's using, speech transcription and then text to speech on the output, but then a bunch of NLP in between as well to understand what it is that you meant. Auto-completion, even when you're typing on your phone and you mess something up and it recommends the next word, that's using NLP. And then every time you write an email, right, when fire that off, it's going through some sort of classifier to try and detect whether it's spam or not, which is also using all sorts of NLP techniques. So it's really kind of around us everywhere, and that's partly because text is just such an omnipotent form of data, right? And it captures everything that we do as a human race. So let's jump into really how you can get going with NLP as fast as possible. And for me, I always recommend that, regardless of your skill level, even if you have the skills to be able to build yourself a sophisticated neural network to do some processing, don't do that first, right? You're always better off trying something that's already been built and is usable and gives you instant results. And having that as a baseline, because if that's good enough, you've saved hundreds of hours, potentially months of your time. So yeah, the best way to get started is definitely to try public APIs. I'm going to give you an example and a demo of one of IBM's one, but there are tons out there. So search the web. There are some, nearly all of them are free to use to a certain point, so they'll give you a trial and then you can play with them. But there are things for all sorts of stuff. Like I've used publicly available thesaurus APIs and things like that to be able to find synonyms for a word. The one I'll show you quickly is IBM's Natural Language Understanding. You can access this through IBM Cloud, so go and sign up there if you don't have an account already. Essentially it bundles a whole bunch of pre-trained natural language classifiers into one product. So here are some of the things it can do. Categorization. So if you throw text at it, you can get the categories out from hierarchy, and it will break it down. And this will make more sense when I show you it in person. Concepts, so understanding the concepts within the text, the body of text that you've sent it, the emotions that are used within there, and where they target certain objects within a document. The ability to pull out keywords, relevancy of those to the article and to other things within the article, and then entities as well. Entities are kind of a little bit like keywords, but they're more like proper nouns in terms of, they're like people, places, companies, organizations, a kind of real world phenomena that we've attached names and labels to, rather than, keywords might be, newspaper might be super relevant to your body of text, but it's not an entity, right? Whereas the British Broadcasting Corporation is an entity, right? Even though they're a news provider. And then, the usual tracking of sentiment as well in there to be able to understand whether the text is positive, negative, neutral, and where that targeted sentiment is within the document. So let me just jump out of here and give you a quick demo. This, if you want to find it, as I said, it's at cloud.ibm.com, and then search for natural language understanding. It's under the AI APIs. I'm going to show you this quick demo so that you can see the kind of things you can get from it. So I can give it this text here, but I thought maybe it'd be more fun to try it in a URL. So let's go for call for code. Let's try and grab a page from here. Let's do the challenge overview. Yeah, that'll work. Hopefully. Let's put this in as a URL. So what I'm doing is I'm giving it the URL to that page, the global challenge, and then I'm telling the API to analyze all the text in that page. So you'll see here at the bottom, let me zoom in a bit, the overall sentiment was positive. It's actually 0.82, so 1 would be totally positive, 0 would be totally negative. The emotions detected in here, there's a lot of joy, a lot of very little anger, tiny bit of sadness, probably because we're talking about how we're trying to tackle some of the depressing issues that humans have in terms of climate change. If we look in to keywords, the global challenge, open source solutions, climate change, it's clever enough to understand that just the word climate on its own isn't the keyword, but actually climate change is the keyword. And then if we're looking at the entities, it thinks Code Global Challenge is a company, so maybe there's an example of something it didn't get quite perfect. It's categorized this as a business software article, which I think is probably as close as it would get. And then if we look at the concepts it detected, we can see things like open source, weather, open source software, climate change, problem solving, computer program. These all seem like really spot on, right, in terms of categorizing and finding the concepts within this web page here, where actually it has very little text to go on. It's got the, what is the Call for Code Global Challenge, and then the focus areas, and just some stuff around the prizes and the judging, right? So it's done pretty well there. And then you can find things like syntax, so parts of speech in there. But one of the really cool things you can do is find out actually, the relations within those. So it breaks down within the sentence the different ways that subject and action and object fit together. So here it understands that you are a subject, and the action is joining, and it's the object is the fight against climate change. Alternatively, right, it also detects that you as a subject, and here's another action by deploying open source solutions being the object. So you can do all sorts of clever things just with this API, and it's all pre-trained and ready for you. You just essentially you throw text at it and you get JSON back. So I can show you an example of the payload you get back from it, and that will it's all documented under the API reference. But let me maybe take the emotion one, be easier to see. You'll see how you just get a JSON object back, and it will give you those confidence scores for each of the attributes that it's returned. Okay, so as I said, that's definitely the best way to get started if you can. is to use one of these pre-trained models. One of these readily usable APIs. The next best thing to do, if you can't use a public API, is a pre-trained model, right? And I always say this again because often you'll find that there isn't a publicly available API for the type of problem you're trying to solve. Maybe you want to classify images, loads of different types of bird, right? And you can find a really good classifier that will tell you whether it's a bird or not, but that's not helpful because you know that your pictures are already all going to be birds and you want to detect which one is which type of bird. That's where maybe it's not publicly available as an API, but actually someone's possibly trained a model like that before and made it publicly available for you to go and take and deploy yourself. So pre-trained models are definitely the next thing to try. They tend to be more domain specific and a bit more technical to implement, but still way quicker than trying to build one yourself. So as I said, building models is hard, right? Firstly, it requires data collection, aggregation, cleaning. There's tons of work and you can spend months doing that. Then it comes down to model selection, knowing which algorithms to use and trying different ones and seeing which perform well. Then the actual training itself, which if you have tons of data, it can take days, even on cloud infrastructure. And then after that, the testing, the evaluation, hyperparameter tuning, there are tons of things that can go into this before you have a decent model that can categorize things or, generate text or analyze sentiment or whatever it is you're trying to do. So wherever possible, see if there's one that you can work with already. As I say, let someone else do the work, right? There are a couple of places I would point to look. In fact, the first is to ignore this slide and say, with nearly all of the machine learning frameworks that you can use, things like scikit-learn, XGBoost, TensorFlow, PyTorch, a lot of them have just examples built into the actual framework itself, and they have pre-trained models in there that you can use too. So what I'll do is I actually show you one of those. So here, this code I have here is essentially running I'm using TensorFlow, but I'm importing this ResNet 50 model, which TensorFlow comes bundled with. It's kind of pre-trained, ready for you to use, and it has a bunch of pre-processing functions as well that I need as part of it. So essentially, with just a few lines of code here, what I can do is I can load that model. I can give it an image path to an image that I have. So apologies, this is actually not a natural language processing one. I've picked a bad example, but it's computer vision. The same kind of way of tackling the issue still applies to natural language processing. You might import instead an NLP library from here, a model that's been pre-trained. So I'm giving it an image path here, and then I'm saying essentially I'm just loading it into a target size of 224 by 224 pixels, so I don't have massive images. Converting it to array, expanding the dimensions, and then pre-processing it, and then I can just run this model.predict, right? And then what I'll do is just print the prediction, and we can see the results. So let's go ahead and run that. So what did I call it? ResNet. And by running this, essentially what it's going to do is take that local image, which actually let me show you that first. Okay, which was just a picture of an elephant, right? And then I grabbed this from Google, so you can do it with any images. Throw it into the classifier, and you can see actually, it's predicted pretty well there. It's fairly confident it's an African elephant. There's a bit of confidence that it's a tusker, which I guess may be another word for an elephant. And then it's got Indian elephant here as well, but very low confidence. And that's impressive, even that it's been trained on different types of elephant, because I wouldn't have assumed as much. I would have thought it would just come back with elephant. So there you go. You can kind of see how quickly, just with a few lines of code, you can use a pre-built model that someone else has trained. let me jump back. So the next thing to try then is, if the examples and the models that come with the libraries don't work for you, you can find them on things like TensorFlow Hub and PyTorch Hub. So here's TensorFlow Hub. If I took like these text problem domains here, let's have a look and see. They break them down quite nicely for you. So I could say, let's say I want to do some text generation. Right, that's a problem that is pretty difficult to do from scratch, and you could spend months or years with a team of researchers building a decent text generation model. Well, you can actually take one already from TensorFlow Hub and then test that out yourself. A lot of them offer the ability to do transfer learning and tweak them yourself so that they work a bit more into your own domain. So yeah, we could take one of these. You see, for example, this smart reply. What does this do? Pre-trained model optimized to work with TensorFlow Lite, so you can deploy it on mobile, things like that. And I think this model is dealt with like chatbot type scenarios. So coming up with recommending the right response a computer might give. Equally, PyTorch, similar library to TensorFlow for machine learning and deep learning. They have their own hub in there as well, so you can jump into these examples and grab those models and deploy them yourself. Okay, so that was taking pre-trained models and trying to work with them. The third option you have, which I wouldn't recommend unless you're experienced in the field, is to build your own model. It's much more time consuming, but obviously you can solve much more complex problems and problems that haven't been tackled before. And that's really where it comes into its own. I would say to people that may be new to this, right, I'm going to give you a few kind of quick tips on things you can do that might get you a small chunk of the way towards what you're trying to achieve, rather than trying to explain everything about building your own neural network here, right? Because we could be here for weeks. So the first thing I'd say to do is that text data is really difficult to work with, because it's so different every time you look at it, right? That people have different writing styles, they use different words to mean the same thing, they use punctuations, emojis, etc. It requires loads of pre-processing, and almost the pre-processing that you do for any model, whether it be a super complicated neural net or just a really simple regression model, the pre-processing is the most important step. If you give your model garbage data, the input, you're going to get rubbish responses on the output. So let's look into some stuff you can do with that, right? Let's say you were looking at tweets and you wanted to analyze those. Well, maybe it'd be important just to use things like regular expressions, strip out HTML tags, things like usernames. Those aren't important to the actual content of the tweet, and they can really create a lot of noise in your model or classifier or statistical analysis, whatever it is you're trying to do. Tokenization is something that's nearly always worth doing, in terms of taking a sentence or a paragraph and breaking it down into individual tokens. So in this case, I'm doing word tokenization. I'm taking this sentence: the greatest wealth is to live content with little, and then I'm basically splitting it on every space and just saying I want to create an array around that. That's important because it means now within in this case in Python, right, I can then iterate over that array. I can do counts, I can do, and I'll show you some sort of statistical models you can build around that in a minute. Stop words, these are words that often come up very frequently within the language, not necessarily English, but don't add much to the meaning or content that you're reading. So if we take this example here, right, be kind, for everyone you meet is fighting a hard battle. If I stripped out the word, for and you and is and a, right, all of those kind of things don't add much, and they probably appear loads in every document. I can shorten that down to be kind, everyone meeting, fighting hard battle, right? And I've maintained probably 99% of the meaning and the content of that sentence, but I've stripped out 30% of the words. And that can be really important in terms of training a classifier, trying to reduce the number of parameters and input features you need to have. Stemming is a way of, again, trying to understand words that are different in string format but potentially have the same meaning. So if I took magical, magician, magically, I can strip away everything after the stem, which would be the word magic, right? So the AL, the IAN, etc. Break it down to just its stem, and then again it means I no longer have duplicates around my. If I was looking at loads of text with all of those words in it, I understand that magic has been referenced a certain number of times, right? Whereas if I counted each of the words individually, I wouldn't get that analysis. You sometimes have to be a little careful with stemming because sometimes it can change. It actually can change the meaning of it a bit, and I'll come on to lemmatization as a better approach in a second. Before you do that, though, something you'd need to do if you're going to do lemmatization is part of speech tagging. And this may just be useful for whatever problem it is you're trying to solve anyway. But being able to understand, the measure of a man is what he does with power, right? This sentence. Actually, as a human, we can kind of figure out that, which part of it is a noun and what's a verb and so on. But it's quite a challenging thing for a computer to do. There are within the libraries, lots of pre-trained models, etc., that will generate these parts of speech, which then allow you to build your own statistical inferences and models around it. So yeah, definitely something to look at. And if you want to do lemmatization, you'll need the part of speech for each token or word within your sentence. So what is lemmatization? Well, that's a bit like stemming, right? We're trying to break a word down into its kind of short form or its base, but in this case, we're trying to understand, what's the actual, and the word is called a lemma, right? Which because it's basically the base stem for where all of the words come from. If you take these examples, was, is, and are, right? They actually all part of the verb to be. But if we were using stemming, we wouldn't get that because we were just looking at each character of the letter and trying to break it down, by just chopping things off the end of it. If we understand the part of speech, so if we know that they're all verbs, then we know that the word is and are and was actually all refer to the same verb be. And so we can put a substitution in, and again, we're massively reducing the number of input features we have, but more importantly, we're understanding now that all of those things, was, is, and are, actually have the same, if not very similar meaning. We could do the same, if you take, actually a good example here is meet and meeting, right? Because meeting can be a noun and meeting can be a verb. And that's where if you're stemming it, right, it will just break it down to meet and you won't understand that potentially that was a noun and it shouldn't have had its end chopped off, right? Whereas with lemmatization, if you give it, meeting the noun, it remains meeting the noun. But if you give it meeting the verb, it'll break it down to meet because that was the actual base verb. In terms of, pre-processing, another really good way to analyze things is to use this really basic concept called an Ngram model. So the simplest of these is a unigram or a 1 gram, often known as a bag of words. I'll explain that a little bit more in a second. But essentially, all we're doing is taking a window and placing it over n number of words, and then generating features from that. So let me show that with a demonstration. So let's say it's a 2 gram model or a bigram model, right? I basically take the first 2 words and then I create a tuple, but only the, and then I'll do the next for the next 2 words, the dead have, etc., right? All the way through this sentence, only the dead have seen the end of war. And I'm essentially generating word pairs. Now, why would I do this? Why is this important? Well, if I take every word individually, I often lose a lot of the context that's surrounding that word. This sentence actually isn't a great example, but if I used just any sentence that referenced call for code, if I was using each individual word, I wouldn't understand that the word call there does not refer to a telephone call or a call to arms or call for action or whatever. It's like it refers very specifically to the event call for code or the initiative, right? That's where breaking down things into n-grams can be really important and really interesting. It may just be that you want to analyze, like if you took the works of Tolkien, for example, right, and then broke down a whole load of things into different sized n-grams, you could see which words are most frequently used together. And often, characters' first names and last names you'll see appear over and over and over again. The good thing to point out is, if you want to get started with this kind of thing, you don't have to do it from scratch. There are libraries like I'd recommend NLTK, Natural Language Toolkit. It's a really basic one for a lot of text pre-processing. Will do a lot of it for you and has some great tutorials. That's definitely a good place to start, but there are other things you can work with like Spacey. So if I show you this example here, right, what I'm doing is I'm going importing the word tokenize function, and then I'm saying, here's my data, I pledge to be a data scientist one day, and then feeding that into word tokenize function, and I get returned a list of each of those words have been split and tokenized. That looks really simple on the face of it. You think, actually, I could write a couple of lines of code, maybe even one line of Python to do that. But there are a lot more complex tokenizers you might do, like there's a tweet tokenizer, for example, which automatically will strip out all the HTML and usernames and hashtags and convert emojis into relevant pieces of text and stuff like that. Use the libraries that are available to you. They'll speed up your work a lot. And then having done a bit of pre-processing, a couple of really simple models that you can work with and at least get some results if you haven't done any machine learning before. The first to look into is a bag of words model. It's basically an n-gram model where n is 1. So essentially I'm just saying it's like a word count, a word frequency. And the way this works is, let me give you the sentence. There are 2 owls wearing 2 hats made for owls. Here they are, these 2 owls. And if I look at the sentence and just basically take a frequency count of each word in there, you can see that there are wearing hats made for all appear once, and then 2 and owls appear twice. Right, that's it. A bag of words model. It's really simple, but what it does is it allows you to start identifying what are the frequently used things, and particularly where you've extracted stop words that weren't relevant. Now you can start to understand, well, maybe I can categorize a piece of text by looking at the most frequent words in there. If I give you another sentence here, there are 2 owls wearing 2 hats made for owls. And I give you another sentence, the owls were having great fun in their hats. Third sentence, owls love wearing hats. Right, I can then break all of that into a bag of words model that counts the frequency of each of those words for each sentence, right? And this is where you're starting to build up a bit of a matrix around this. Along the top, we have all of the unique words that were used within our sentences, or our corpus as it's referred to. And then each of the sentences will have counts based among them. And now I can start looking at these numbers and inferring, because it's all now been converted to numbers, I can do statistical comparisons on this. I can say, actually, which sentences have the most words in common, which sentences also have the same high frequency usage of the word owl, etc. Right? If I do this over, mine's a very trivial example with only 3 sentences, but if I did this over a huge corpus of documents, actually I can get some really meaningful results, even with a really simple model like this. If I wanted to go a little bit further and make it just a tiny bit more complex, but still very simple and basic, I would take my word frequency, which was my bag of words model, and then do something called a TFIDF model, or term frequency inverse document frequency. That sounds really confusing, but when I break it down, you'll realize it's actually a very simple scenario. The way it works is you have this term frequency, which is how often each term or word occurs within a document. And that's basically what we just did with the bag of words model. We just counted up how many times does the word owl appear in this sentence. And then you also have the document frequency, which is how often each term or word appears across all documents in the corpus. Right? And the reason that's important is because if my document I'm looking at has the word owl mentioned loads of times in this document, but owls are not mentioned anywhere else in any of the other documents I'm looking at, then that means that the document I'm looking at, or the hypothesis is that the document I'm looking at is probably very relevant to owls, right? Whereas if it has the word owls everywhere in mine, but it has owls across all of the others, then it's probably not super relevant to owls, right? Because all of them are relevant to owls, if you see what I mean. I'm probably reading from an owl encyclopedia, if such a thing exists. That's essentially the hypothesis behind it. And it eliminates the biggest problem with the bag of words model, which is that frequently occurring words such as stop words like and or I or am, or, all of those, if you don't remove them, you'll find they just come up really, really frequently, and it looks like your document is just about was and is, and that's not particularly helpful. So yeah, the term frequency inverse document frequency handles that problem. The inverse document frequency is calculated as the number of documents over the number of documents that include the term, right? And then we take the log of that. And if I combine the two of them, so that's my inverse document frequency, which is the log of the number of documents over the number of documents that include the term. And I'll show you this with an example, so don't worry too much about the maths. And then I just times that by the term frequency that I had, which was my bag of words model. So if I take three very, very simple sentences, the warm water, the cold water, and the murky water, right? There are only 3 words in each of those. If I use my bag of words model, would each unique word down the left-hand side. Let's take the word the in the warm water, right? It appears once, so let's go back to the formula. So the term frequency is 1. The inverse document frequency will be, the number of documents, which is 3, over the number of documents that the term appears in, which is 3 as well. So I now have the log of 1, which is actually 0, but you'll see that mine comes out as 1, right? Why is that? Well, in my example, and I probably should have included this in the slides, what I've done is basically I've added 1 to every result, because what I don't want to do is have a scenario where I don't account for any of the words in the document. And the best way to explain this is if you look at these numbers here, you'll see that the word warm is much more relevant to the first example than it is to anything else, right? Even more so than the words the and water, even though it appears the same number of times, right? That's because it doesn't appear as much in the rest of the examples. And the same for the words cold and murky in the other examples, right? The issue is if I don't do some sort of smoothing where I add 1 to the formula afterwards, then actually I get zeros for the and water as well, which isn't hugely helpful if I want to understand whether my document is potentially about water, right? Because that's still pretty relevant to it. It's just not as relevant as the word warm. So that was a super quick example. Again, it's something, if this is not making any sense, don't worry about it at all. As I said, use a public API first if you can, then use a pre-trained model. If this is making a little bit of sense, or it sounds like something that might help you tackle one of the problems you want to try and solve, look into it a bit more. TFIDF, look at scikit-learn as a Python library. It makes it really easy. Just these 3 lines of code here will do that calculation for you, so you don't particularly have to worry about the maths and understand it. You just can look at the statistical outputs of it and then try and create some models and some great solutions around that. Thank you very much for listening. I appreciate that was a kind of whistle-stop tour of everything NLP. If you have questions, you can send me an email, you can tweet me at UK Cloudman, and I hope you will build some really awesome things. I'm looking forward to seeing the results. So thank you.